let's address an elephant in the room. Backend development never ceases to amaze us. It's never what we think it is. For example, did you ever think that backend development is not only about service-oriented architecture or monoliths or microservices? It can also be a system with plugins like your IDE. Hi, my name is Pasha Finkelstein. I work as a developer advocate for Bellsoft, and today we are diving into plugin systems for backend. The tool we will be talking about today is called PF4J. PF4J stands for Plugin Framework for Java. You could think that framework is something huge, like megabytes, like Spring framework is, but actually PF4J is only around 100 kilobytes. It's tiny and very simple. What is a plugin anyways? You could think that plugin is just a part of your application which is developed by a third-party developer. It doesn't matter if the third-party developer is actually inside your huge organization or you are a sole developer of your application, but you give ability to other developers to create parts of your applications. For example, imagine you have a web application which is a web interface for a library or something, and you are willing to implement only one file type support, for example EPUB. But there are many other formats, right? For example PDFs, MOBI, Markdown, whatever. You're not willing to develop this functionality, but you are willing to provide other developers with ability to develop this functionality for you. To do it, you create an extension point. And yes, extension point is how it's called inside PF4J. It's a point in your application where custom code can be invoked. For example, if you just need to get a path to a book, then you can say, this extension point is actually an interface with one method called getPath or something like that. Does plugin consist only of extension points? Not necessarily. Plugin actually can have a lifecycle, and during this lifecycle, plugin essentially loads, starts, runs, and then shuts down. It can do several actions, any actions you will, on startup or on shutdown. And these three concepts, extension point, plugin, and extension, are actually three core concepts on which PF4J is built. PF4J, even being a small library, actually supports a lot of interesting technologies. I would like to focus on PF4J Spring, because Spring is the main framework we actually use in our production, right? PF4J is also very interesting, but not for web applications. I would say that it's more suitable for desktop applications. And if you are developing a desktop application, then feel free to look at PF4J update 2. How PF4J Spring is different from usual PF4J? There are not that many differences actually. For example, PF4J Spring allows you to work with Spring application context. It means that you can access your application context and any bean residing in it from inside your plugin. It might be useful if you wanna inject something inside your plugin. Now let's dive into a small code example. Let's look at a small project I prepared specifically to demonstrate PF4J. You can see on the screen my small project called PF4J Demo. It contains several modules, commons, where I will store my extensions, and my main module is just a Spring application containing application runner, controller, and Spring configuration. We will talk about them a little bit later. Now, let's look at the commons module. If we look into its dependencies, there is only one dependency in my case, it's org PF4J, and I exclude org SLF4J for it not to conflict with Spring in the main application. And it contains only one class, only one interface actually, called phrase extension point. As you can see, this interface extends interface called extension point, and the interface extension point is just a marker interface needed for PF4J to validate that we do something right. In my case, this interface contains only one method called phrase of the day. It means that any developer who wants to provide their own phrase of the day should implement one method called phrase of the day in their plugins. Now let's look into plugins, which are the most interesting part in case of our talk. For example, I have two plugins here. One of them is called Buy plugin and one of them is called Hello plugin. They both are very simple. They just return one string from the function phrase of the day. You can see that it's just an implementation of phrase extension point called Buy extension, and it just returns buy when we call phrase of the day. The same happens inside Hello plugin. Phrase of the day, it implements phrase extension point and returns hello. More or less predictable. What is more interesting is to look into build Gradle KTS. For example, for Buy plugin, here is how my build Gradle KTS looks. There are three dependencies. One of them is PF4J compile only. The more interesting part is we have this annotation processor dependency, which means that Java-C should process our files and create some generated code. We'll look into it a little bit later. We also depend on the project called Commons because, well, obviously our interface, our extension point is defined in the Commons module. Also, we need to define some attributes inside manifesto of our plugin. Here I put only three of them: plugin ID, which is Buy plugin in our case, plugin version, which is just project version, and plugin provider, which is Belsoft, because this way I work, right? You'll see they're absolutely the same in Hello plugin, obviously. And I also have added a couple of tasks in my main Gradle file. I created a task called copy plugins, which depends on build of both Buy plugin and Hello plugin, and it takes their outputs, jars, and put them inside the plugins directory here, like just as jar files. And then just for the sake of transparency, it prints me where did it put all the plugins it found. You generally do not need this setup in your production environment, but since it's a demonstration project, I want to show you how it will work inside Spring application. This is probably the easiest way to make them accessible for Spring application. Let's quickly look at what happens when we package our plugins. For that, we should open our file in Finder. Now we can open it as a usual archive because jar is essentially just a zip file. And we can see that we have, as expected, package with my code, which is just an Buy extension class. But also there is a Metainformation, which contains two files. One of them is extension IDX, which contains these two lines generated by PF4J, and then the full class name of my extension class, which is being used by PF4J internally to find actual extensions. And also there is a manifest that has several additional lines: plugin ID, plugin version, and plugin provider. Actually, the manifest can be much longer. For example, plugins can depend on each other and so on. But since it's just a simple example, we can stop at this point. Now we are switching to the most interesting part. How is it used inside the Spring application? Let's switch to the main codebase. As I already showed you, there are several classes. One of them is just an application launcher, which does nothing but just runs PF4J demo application class. Another is a phrase controller. Phrase controller does very interesting thing. It has a list of phrase extension points as its dependencies, and then it has one mapping / phrase, which allows us to get all the phrases of the day from all the extensions we have, collect them joining new line, and then just return. But probably the most interesting place is this class. It's a Spring Plugin Manager. Spring Plugin Manager is an implementation of Plugin Manager for PF4J, specifically bound for Spring. Usually Plugin Manager is very simple. It's only responsible for loading classes you tell it to load, but in our case, it is actually Spring aware. It means that when we create an instance of Spring Plugin Manager, we can put an application context inside it. Then we call init on Spring Plugin Manager. It finds all the plugins and extensions there are in our plugins directory, and then it returns the bin of type Plugin Manager. I should tell you one thing more. Phrase controller here depends on Plugin Manager. We need this line just for it to load after our Plugin Manager is initialized, because otherwise there is a risk that our extensions won't be available in class path. Now we can start our application and see how it actually works at the end of the day. This is why we are here, right? Let's run it. Give it a second. It's running. Now let's make a request. And we see, well, there are some issues with IDEA, but you can see that it actually returns hello and bye, exactly as we expected. And this will be your introduction to PF4J. It allows you to create flexible web applications. You can actually build a monolithic application with several plugins and deploy it with several sets of plugins on different nodes. It also can be a way to scale your application in a flexible way. You suddenly realize that you need more nodes with support for something, and you just deploy the same application with one additional layer, which also contains support for this in a separate plugin. Think about it. You're not obligated to deploy an application which includes everything. Now you're liberated. You can deploy only those parts of applications you actually need and still have a monolithic or modular code base. And essentially, I would say that plugins are just modules and a way to load them. It's worth nothing that plugins can contain their own libraries of different versions. So if a different team wants to create a plugin for your application, they're very welcome. They can use any JVM stack they want. They can use any libraries, and they won't break the functionality of your application. With that, I hope that you have some understanding of PF4J. You're very welcome to ask your questions. See you next time.